Good day everyone. So for today's video, we will be tackling about F-test for ratio of variance. So what is an F-test? An F-test is any statistical test in which the test statistic has an F distribution under the null hypothesis. So it is most often used when comparing statistical models that have been fitted to a data set in order to identify the model that best fits the population from which the data were sampled. So I have here an example and let me read this for you. So is there a difference between the variances of the number of weeks of the bestseller list for nonfiction and fiction books? 15 New York Times bestseller fiction books had a standard deviation of 6.17 weeks on the list, and 16 New York Times bestselling nonfiction books had a standard deviation of 13.12 weeks. So at the 10% significance level, can we conclude that there is a difference in the variances? The variance squared of fiction books is not equal to the variance squared of nonfiction books. So it says here that can we conclude that there is a difference in the variances. So our claim is not equal. Next, we need to write the um, null hypothesis and the alternate alternative hypothesis. So our alternative hypothesis is same as our claim. So we only have to copy this. Variance squared of fiction books is not equals to the variance squared of nonfiction books, and our null hypothesis should be the opposite of our alternative. So variance squared of fiction books is equals to the variance squared of nonfiction books. So next, we need to write down the data of the example. Data of fiction and non-fiction books. So our N here is 15 in non-fiction books because it says here that 15 New York Times best-selling fiction books had a standard deviation of, so our standard deviation here is 6.17. So our N in nonfiction is 16 since it says in the example that 16 New York Times best-selling nonfiction books had a standard deviation of 13.12, and our alpha is equals to 10% or 0.10. So now our formula of this problem, or the F-test for ratio of variance formula, is F is equals to the standard deviation squared over the standard deviation squared. So keep in mind that in our numerator, we need to use the larger formula or the bigger one. So we need to write the standard deviation squared of non-fiction books over the standard deviation of fiction books. So 13.12 squared over 6.17 squared. So we need to calculate this. 13.12 squared divided by 6.17 squared. So the result is 4.522. So this is the answer. So our F test statistic is 4.522. So now we need to compare our F test statistic in our critical value. So this is an F test, and this F test statistic has an F distribution. So the curve for F distribution looks in so many cases like this. It occurs depends on the degrees of freedom involved, but typically it looks something like that. So it's an right skewed distribution, and what we need to do then is to find a rejected region. So that will be in the upper tail. So we're looking for an F value right here. So this would be the critical value that separates the rejected region from the do not reject region. So, there's the idea. The critical value for a two-tailed test, which is what we're dealing with here, is going to have an alpha of half of the value we started at. So we're going to do when we have a two-tailed test is to chop the alpha into half. So we're going to use 0.05. So you only do that when it is two-tailed test. But if it is one-tailed test, you just put the alpha, this 0.10, in this right tail. So now we need to look up the degrees of freedom. So there's going to be there's going to be 2 degrees of freedom for this F value. So we're gonna have the degrees of freedom for the numerator, which is this, and the degrees of freedom for the denominator, which is this. So 16 minus 1 is equals to 15, and 15 minus 1 is equals to 14. This is the value that we need to look up on our F table. So 15, the 15 degrees of freedom on is on the top row, and the 14 degrees of freedom is the in leftmost column. The corresponding value of it would gonna be our critical value. So now let's take a look in our table. So our critical value is 2.463. So we need to write it here 2.463. And when we look at our F test, they are not equal here. They are not equal. So it means that our HO is rejected. So our HO is rejected, and support our HA. So I therefore conclude that um, the sample data support data support the claim, since our claim and our HA is the same. So that's all. Thank you.